I'm standing here in front of Paradise Pond, and what you can see here is the dam, and down there at the bottom is a hole that has a gate. Over there is the hole that has a gate in front of it that can go up and down. So we can control whether water comes through there, or only if it's closed, it only goes over the top. So Smith can control how much water goes through there, and if we open it all the way, that actually allows the pond to completely drain, and so it becomes more of a river instead of a pond. And just like any river system, sediment runs down whenever, especially during rain events. You get a lot of wash off erosion into the river, and sediment runs down the river. That's a natural thing that happens in rivers. But because of the dam, that stops a lot of the sediment from going down the river, and the sediment builds up in the pond. So what we try to do over time is try to not lose our pond, because Paradise Pond is an iconic part of Smith. So we want to make sure that we can maintain the pond and that it's not just a bunch of islands, and so we can actually boat across the pond, and it's still a pond. So what we used to do is dredge the pond. So we would pull down the sluice gate, let all the water drain out, let it dry out, and then remove the sediment with bulldozers to the landfill in Northampton. That has become a problem for many reasons, including the landfill closed, so we have to send sediment further away. But also in 1998, there was a dredging that we did then that we couldn't, there has to be enough flow in the river for us to close the sluice gate. Because if we close it when the river is really low and not flowing very fast, it takes too long for it to fill up and overflow, and then we're starving the river downstream of water. So we can't close the sluice, once the sluice gate is open, we can't close it unless we have a certain amount of flow. And that year the flow was too low for months, and it was till I think they did the dredging in the summer, and they weren't able to close it again until the end of October. And that caused a lot of problems. And so the town and the state have been really interested in avoiding that kind of situation to happen again. So we've changed over to a different sediment management system, where instead of dredging and removing the sediment from the system, we now do what's called a partial drawdown, where we draw just a little bit of the water down, let it dry out a little bit, and then we just use a bulldozer to push the sediment from where it builds up to where it erodes. And then that will, it basically takes the sediment and builds it up more in front of the sluice gate, and then on a big storm, we can open that up and it flushes downstream, and that way we can let the sediment stay in the system rather than removing it from the system. So that's in general what Smith is trying to do, is to manage the sediment but keep it in the system. And in order to do all of that, we have to get permits. And in order to get permits, we have to do a lot of research and monitoring in the river. So my part of the project is to monitor the macroinvertebrates in the river to see if they're being affected or impacted by our sediment management. So I sample downstream of the pond as well as upstream of the pond. What's showing here is the downstream area. So we're actually on Lamont Bridge looking downstream. So you can see the whole downstream area. Right now, over the summer and this fall, the flow rate has been very low. So you can see that the water level is very low. So a lot of rocks are showing. Most of the time, these rocks are all underwater. The grassy area is usually a little bit out of water, but sometimes even that area is completely underwater. Within this area, I call this my downstream location. There are 5 sub-areas within this location, which I call microhabitats. The 5 microhabitats within this area, starting from the furthest downstream, is what I call DSR, or for downstream and rocky, because there are lots of rocks. And it's in this view on the right-hand side over here. Then a little bit further upstream the water flow tends to be a little bit faster, and so I call that the downstream fast rocky, or DFR. Then under this area of trees, it's very shady and very fast flow usually, and that is downstream shady, or DSH. Then just downstream of this grassy area, there are actually some freshwater sponges, which you can't really see from this view, but oftentimes there are freshwater sponges in this area, and so I call this DSP for downstream spongy. And then in the middle of the river is just downstream middle, DM. So those are the 5 areas where we sample from. So what we're seeing here is the upstream location. The upstream location is kind of split into 2 areas for historical reasons. And like the downstream area, there are 5 microhabitats within the upstream. Within this chunk of the upstream, there are 2 microhabitats. The first one is under these trees here, where it's much shadier. So this is the upstream shady, or USH, and it's similar to the downstream shady, in that it, in higher flow rates anyway, the river is really slow right now, but when there's more rain and there's a faster flow in the river, it's a very fast flow and shade, and it's very similar to the downstream shady microhabitat. Moving downstream a little bit, you can see that it gets sunnier, although it is cloudy today, so it's not dramatic. But more in the center of the river, in the sunnier area, is the USU, or Upstream Sunny Location. And the Upstream Sunny Location is similar to the Downstream Sponge Location, and that it's, in some places anyway, fairly shallow, and since it's not under trees, gets a lot of light. So this is the last area that I sample in. We're still in the upstream area overall, the upstream location, but we're a little bit downstream of where we just showed you in that other video. So we were a little bit further up over there. And this area, we sample 3 microhabitats. One I call the upstream fast rocky, or UFR, which is just right in here, which normally is faster than it is right now, next to this really big rock. So this area, there's a lot of larger rocks, and the water tends to be a little bit deeper than some of the other spots. Then moving a little bit downstream, but also to the middle, you will see a lot of bigger rocks kind of poking out in the middle of the river. And in that area, you can see the water's moving a little faster. That's one of the fastest areas of water flow in this section of the river. That is the upstream middle. So that is equivalent of the downstream middle. So it's kind of in the middle of the stream and fairly high flow. Moving down a little further, there's these larger rocks kind of right in front of us, and then it's very, very slow flow downstream of these rocks. Right now it looks like there's barely any flow at all. And this is the downstream slow, and they're still rocks, so rocky. So I call it, upstream slow rocky. So it's USR, which is similar to the downstream, which is DSR. So those are equivalent, somewhat equivalent anyway. And you can see the flow is very slow. It's sometimes shady, but also sometimes sunny. This area of the river is much wider, so you can see that it's a much wider part of the river, and right now the water is so low, you can see a lot of it is actually in the air rather than covered in water, but at other times of year when the water flow is higher, there's water over that area. So those are all the areas we sample in.